Hi, my name is Paul, and today I will be talking about the pushover analysis as a tool for seismic performance evaluation. First, we have to talk about what is a pushover analysis. Well, this is a type of analysis that increases the loadings in a structure in order to find the load path in which it forms the collapse mechanism of the whole structure. The final result of the analysis is the collapse loadings and the moment curvature graphs of all structural members. Then we have to talk about the seismic design process. The seismic design process is often seen as a two-step cyclic process. The first step would be the conception of a structural system. The main objectives of this step are the serviceability, the life safety, and the collapse prevention of the structure, and also the financial and deadline constraints of the project. This step is often based on the engineer's judgment, experience, and knowledge of ground motion. Also, the knowledge of elastic and inelastic dynamic response of the building. The second step would be the evaluation of the structural system performance. We tend to look at all structural members and look out for their strength, stiffness, deformation capacity, displacements, deflections, and cumulative deformation. So, why apply it to seismic design? It provides us with a good prediction of seismic demands, such as the global drift of the whole structure, the interstory drift, the inelastic moment deformations, the connection forces, and how it redistributes the internal forces within the structure. Also, it provides information on the response that cannot be obtained from an elastic, static, or dynamic analysis, such as the estimates of the deformation demands for all elements, the consequences of the strength deterioration of individual elements, the identification of critical regions in which the deformation demands are expected to be high, and the estimates of interstory drift. And most importantly, the verification of the completeness and adequacy of load path, considering all elements of the structural system, all the connection, the stiff non-structural elements of significant strength. This is because the analytical model has to incorporate all elements, whether structural or non-structural, that contribute significantly to lateral load distribution. Lastly, we have some pros and cons for using the pushover analysis. Some of the pros are that it provides a good insight into structural aspects that control performance during severe earthquakes. Also, it is a good estimation on deformation demands. It exposes the design weaknesses that may remain hidden in an elastic analysis. It also shows the overloads in brittle elements, such as columns and connections. But it also has cons. On the negative side, it could lead to inaccurate results for higher structures. The most important one would be that it only detects the first mechanism occurred in an earthquake. It detects only the first mechanisms, and the other weaknesses may not be exposed after the structure's dynamic characteristics changed after the formation of the first mechanism. And the pushover analysis can be implemented for all structures, but it should be complemented with other evaluation processes. So it is not a single method of analysis. Thank you.